Welcome to the second practical stream for Introduction to Programming. Today we'll do something very cool because we will start programming.
That's very nice. So we directly go to the slides. Okay. First, there will be a couple of organizational things that we need to discuss, though. But then we can really start programming. Okay, you have to press today. So we already announced the coding sessions last week, and now we really published them, and now you can find them in the Teach Center. So if we switch to the Teach Center, you can find them here below the homework that you should do already. And basically everything for the coding session is explained here as well as in our Notion. So we have also the link there. So the procedure is for the coding session that you need to register for a slot. You can do this here in these slots for the first session. This looks something like this. And here below, we cannot see this right now because we're not registered to the Teach Center. You can find various slots, various time slots where you register. And in addition, you can also find here the task description, what you should do. So in the case you register for a slot starting from the 16th of October to 19th of October, you need to download this task description here. So we can even do that, I think. Can I open it here directly? Or it doesn't matter. So it looks something like that. So you also have a description of the task. I hope it's large enough in the stream, but you can read it anyways. And if you have a later time slot, then this will be announced approximately a week before your time slot's happening. So you need to do this before the coding session. Then you submit it here in the pre-work for the first session. So this is the second bullet point here. The third bullet point is that you actually attend the coding session, and then you have 48 hours time, so 2 days time to upload the report, which you can find here, which should also work. So this is just, okay, it opens in the window, so you fill out this form and there are some questions about the coding session. Do we have any questions regarding the coding sessions?
I don't think so. So yeah, it's separate from the assignments and the homeworks. Yeah.
And because I read here afternoon sessions, yes, there will be some in the morning and some on the afternoon as well. Yeah, basically what I said already. And there is a second thing happening. So there are these personal question hours which we offer, and yeah, they also start next week. And again, you have the registration in Teach Center, and this is a face-to-face meeting with a tutor, and you do this in groups of up to 5 students. Why so few students? Because then really the tutor can take his or her time to solve the problem that you're having at the moment, and you want to solve it with the tutor. And again, in the Teach Center, you have here the slots for the personal question hours. And
so to differentiate these two a bit more, the coding sessions are like you get points for them. They are not mandatory, but you do get points for them. You can't get full points if you don't do them. And the personal question hours are just for you if you have any questions, so you can ask us in person and maybe get some help.
So this is just optional if you need them. Okay, so these are those 2 points on the Teach Center that you can find from now on. But what about the homework? Maybe you can give us a short recap.
Yeah, just to recap, it's about the topics we did in the last stream, and they're about Git and Linux. And the deadline is next week on the 18th of October at midnight. And you just have to submit the PDF report. So yeah, so the PDF report, that's the thing you have to submit for the homework. So it's not something extra, that's just the homework.
Yeah.
Yeah.
Maybe we would like to ask in the chat how many of you already solved the homework and who is still working on it. Would be interesting.
Mm-hmm.
That looks
Okay.
That looks really good.
So many did it already. Nice.
That's looking really good. Yeah.
Then, yeah, let's get going with a quiz. So I think the Menti code is already in the description.
Yeah, it should be in the description of the YouTube video.
Then you can join us in Menti now.
So maybe we can already switch to the next slide on Menti. Then we probably see the participants. Yeah, and everyone is joining. So please join us, because I think it's fun to join a Menti quiz, and it's also maybe opportunity to see whether you remember something from last week and which parts you remember and which are probably a bit harder for you. And in the stream we currently have how many?
250.
250. Maybe we wait a couple of seconds. Yeah, if we hit the 200, we'll maybe start the quiz, I think.
Yeah, okay, let's start. Okay, so the first question is about Git and how we can practically download an existing Git repository for the first time.
And there are some Git commands as the answers with clone, commit, status, init, and pull. And it looks like you're really fast. That's really cool. So everyone voted before the time ended. That's really cool. And let's see the results.
Okay, so most of you are right. It's git clone. Git pull is maybe a bit tricky, but you use pull if you already have cloned the repository and it's local on your computer. Then you can use git pull to get the latest changes from the online repository. And let's continue.
Yes. So we have a second question about Git. And in this case, we do the opposite operation. So what commands do you need to upload changes to a Git repository? And then we have some answers including different Git commands.
So yeah, we have clone, commit, push, add, commit, push, pull, status, commit, push, and add status, commit. So various commands in various order.
Mm-hmm. Yeah, really good.
So most of you are right. So yeah, that's really nice that you remember so much from last time. But we have one more question.
Yeah.
This might be a bit more tricky, this last question.
Is this also about Git?
No, this is about Linux now. So how to rename a file on the command line.
So it's called a.txt and we want b.txt then?
Exactly. So we have Dutch b.txt, then cat b.txt, cp a.txt b.txt, mv a.txt b.txt, and rm.
If I would know what a Zungenbrecher in English is, I would say that now. Okay, this was now a bit harder.
Yeah, it's tricky because to rename a file, it's the same as if you want to move a file. So you practically move the file A to file B.
And I learned something now. It's a tongue twister. Thank you for your reply in the chat. Okay.
So let's go back to the slides.
Yeah.
Yeah, we did the Menti quiz right now. So now let's continue with the introduction to C. But first, we have yet another question for you.
On Menti, yeah. Do we immediately switch there? Yeah.
Yeah, let's
do that. But this time it's not the quiz.
No, it's not a quiz. It's just who won you will see at the end. So we have a few more questions. during the stream. But for now, it's just let's just continue.
Yeah.
So we just want to get a feeling of how much programming experience you all have.
So in the very first second, the pro really raised, but now it looks more like we have a lot of beginners and also with no experience, which is clear, of course,
because it's an introduction to programming.
Yeah, of course.
So you don't need any prior experience. Yeah, okay. So let's go back to the slides. So maybe let's start with what is C. So C is a programming language we'll use in this course, but what is a programming language? In case of C, it's just a list of instructions you give to the computer, and they are more human readable than what you learned in the last lecture with the machine code and with how instructions are executed. Basically, C is just an abstraction above that makes it more human readable, but it's still low level, meaning that it's very close to the computer and you more or less directly tell the computer what to do. Okay, then the question is, how can we run C? So how can we write code in C, and then how can we run a C program? And the option that we would usually choose is to compile it, and compiling means that we put the code into a program again, and this program then converts or transforms it to the machine code that we've seen before that can really be executed by your computer. But for today, we don't want to do this because that's a bit hard, and we don't want to mess around with those things today, but we'll start with online GDB. Because of course there has to be a step between C and what the computer executes, so someone has to translate it. Yeah. Yes. And now we go to online GDB, which does this job for us. So maybe you can increase the size a bit, as my keyboard is probably not working. Okay, so yeah. So this is how online GDB looks like. And maybe if you like, you can also open it. So you can see the URL, it's just onlinegdb.com. And you have to select C for language. Yeah. And then you can click on run and execute your program. Yeah, exactly. You won't do that yet, and everything that's written there we'll get to later. This is just for you, so you have a quick way of trying things out that we will talk about in this lecture. Yeah. But now we can switch back to the slides, because we can run C in our slides, because Julia implemented this in the last week. So maybe we switch to our Hello World here. So this is exactly the same what you've seen on online GDB, and maybe we can even run it. And here in the last line, you see now that with those two slashes, it's always the output of the program. In this case, the output is Hello World, which is a usual thing that you do if you learn a new programming language, that the first thing you print Hello World with that language. Maybe just quickly compare it with online GDB. We have the same code as here. If we click on run, we see that it's compiled and you see the output here. Yeah. So just you know how to use it. Okay, so this Hello World, maybe we should explain a bit what are the elements that appear in this Hello World program. So maybe let's start with what is main and return. You see it here. You see int, main, and then this void here. So main is basically the entry point, which tells the computer, or maybe the C compiler, where your program starts and where it should start executing your statements, your instructions line by line, more or less. And main is a function, and functions are maybe a bit like commands, because they have inputs and outputs, And this is what we see here, the return value of a function, which is basically more or less the output of a function. And yeah, so let's not stress too much about everything else that's there. Let's just think about it as a function, and it's the first thing we run. If you don't get it completely now, that's also fine. You'll get used to it.
And as I see a question in the chat, is there any advantage to passing this void? Why we write void there, and what else we can write here in this in the brackets after the main? We will discuss this at some later point. I think that's not so much important today.
Yeah, if you don't get what a function is, that's fine. Functions will be introduced in a later point. We just want to clarify what it is that you write here. So it's just not something, I don't know, you have to do.
Then maybe another question is, what is this printf about? And printf is another function. And maybe you can think about printf a bit like a mathematical function. So a mathematical function in mathematics, you get some argument, some x value, and you then produce an f of x or a y. And the exact same thing does this printf now. So it takes, as we already know from last lecture, a string, the string hello world, so this chain of characters. And what it does is it produces an output to standard out, which is then the result of our program that we see, so when we execute it. So this is one question, and now there's just one line remaining, this include stdio.h. Why do we need this? Maybe you can switch to the next slide. Because printf is some function, but how should our program know how this function works? And for that reason, we have a library called stdio, and this library defines the function printf. So it basically provides a description of the function so that the computer knows what to do when we call printf. And in order to use it, we need to include this library. But again, we don't want to stress this too much today. The important thing is here the printf for hello world.
Exactly. And maybe more important, what we will do later.
Okay, then we come to the next part of data types in C.
So you already learned about data types with Alex and David. So now we'll talk about them in how they are represented in C and what you can do with them in C.
Okay, and then we start with probably the most simple data type, which is integer. And yeah, what can we represent with integers in C? It's just whole numbers. So not every whole number, but a lot of whole numbers, namely in the range from approximately, so it's not exact numbers, from minus 2 billion, oder in Deutsch Milliarde, to 2 billion. Why is this the case that we only have a certain range? Because we only have limited memory for an integer. So we already saw that these bits and bytes, and also an integer has only some strict memory limitation, some size, and for that reason we can only represent this certain range. Okay, and then we want to do a short example on integers, and let's figure out whether my keyboard is working. It's obviously not working, so I would like to borrow yours. Okay, and yeah, the first thing that we want to do is we want to create an integer variable. So we write int, so this is the name of this data type for integer, and then we give it a name. For example, I just write a here, and then I assign a value here. So in this case, this integer a would have the value 42. And we can now also do, we can also implement a second integer, and this name not necessarily must be just a single letter, but we can also choose some other name. For example, a name like this. So this is maybe a better name. So usually we choose names that are self-explanatory, so it should be clear what this variable is doing. and maybe we assign it the value 5. So
yeah, maybe let's just talk about what is a variable. If you can explain that for a second, because now you said we're creating a variable, but what is a variable?
Yeah, so I give you now my definition, and then Julia will give you another definition. So if you think about mathematics, then a variable is just a placeholder for some value. And in this case, for this variable a, this is a placeholder for some number. In this case, we explicitly state that this is the number 42, but if we just have an integer a, it could be any whole number.
And maybe another way to think about it, a variable is just references some memory, and yeah, so maybe. Okay, I'm sorry. Yeah, and also a variable is like an abstraction of memory locations. So a variable may refer to a memory location, and variables typically have a type assigned to them, and yeah.
Yeah, so basically you think about this memory that we saw before, and then you specify a location with this name a.
Exactly.
Okay. So we have now two variables, but now I think it's a bit boring right now. So maybe we can even do some arithmetics here, and we create a new variable which we call sum, and the sum should be the sum of those two variables that we had created before. So it should be a plus better name in our case. Okay, and now the sum should be 47, hopefully. And now the question is, how can we verify this is really the case? And we can do this now by printing the result. So we use again this function printf from before, and then we write something like sum, yeah, this should be there. Then I would like to have my sum written there, but I don't know how to do that right now. So that's the way how we saw it before. Yeah, I can run it, right? So in this case, we would have, so we can ignore this for now. We just look on the output, which is in the very bottom. So in this case, the sum would be this xxx because we printed this. And now the question would be, how can we actually print the value of this variable? And
that's a very good question in chat. Does the F in printf stand for something? Yes, and we'll get to that now.
Yeah, oh, that's very, very nice. So this F stands for formatted. So we can specify formats on how variables should be printed in the string. Yeah? And instead of this xxx, we write now %d, and we give as an additional parameter to the printf. So we separate it with the semicolon, with the comma. Yeah, we write the sum, and now this value of sum, the %d will be substituted with the value of sum. Okay, so if we execute this again, then we see, okay, the sum is now 47, which we expected. Okay, was that clear for now in the chat?
I think so.
Yeah. Okay, then maybe to give you some more operations, I would just copy this. So we can also have here, for example, a difference with a minus better name, and then we print the difference, which should be hopefully 37. And if we do this, yeah, that's also working fine. Now there's one question left. This output doesn't look very nice. How can we format this in a better way? That there is a line break, that it looks something like that maybe. And to obtain this, we write here in this string a backslash and the n. And the backslash and the n, oh, there it's already written in the chat, perfect. With this backslash n, we insert a line break in the output. So we can also do this here. And now if we run it again, so maybe I should remove this here and then run it, we get really the output that it's listed below each other. Okay, and then there is one last thing, and I'm interested now. I do now a third operation here. Okay, that's kind of weird. So I will do it directly here. So we calculate now the quotient of A divided by beta name. And I want to print the quotient here as well. Quotient. And now the question is, what is the output of this statement? But please don't write it in the chat, because we have a Menti question about it. So we go to the right. And yeah, what is the output of the quotient thing here? A divided by beta name. So 42, 5, 8, 8.4, or 9. Maybe some were not in the Menti, maybe we should have announced it a bit earlier.
Oh, what are the values? Oops. The values are
42 and 5. Yeah. I'm sorry for that.
Yeah, maybe we should have wrote that
on the slide as well, yeah. Why is 8 the solution? Because if we switch back to the code, this quotient is an integer, so it's a whole number, and if we have A divided by B, by beta name, so then the result would be obviously 8.4, but we can only store whole numbers in an integer, so this 0.4 gets omitted and we just have the value 8. And even if the result would be 8.6, for example, then it would also happen the same thing. We would just omit the 0.6 and we would obtain 8 as the result. So there is no rounding involved.
Yeah, because we are working with integers.
Yeah. Okay, so maybe we do a bit more about integers.
Yeah, your slide on printf.
But it's my slide on printf. But basically we saw everything here. Just to summarize it again, this backslash n is the line break. With this %d, we can replace the string, or we can insert an integer into our string. And we can also, if we want to do and print more numbers than one, we can write several %d in one string, but then we also need to add more parameters to the printf function. Okay, now your part about integers.
Now let's talk a bit more about integer types. We've seen int now, and that it's roughly from negative 2 billion to approximately 2 billion. And that we can print it with this % and d sign. But let's talk about something else, because signed and unsigned, so the signedness of a variable or a type, basically. I have an example here, so maybe it's just clear if I tell you this example. If I have an unsigned int, the range of values is from 0 to approximately 4 billion, so double of that before. What this means is that if we write signed int or just int, that's the same, and int is default is signed, then we use 1 bit of information to store if it's a negative or positive value. It's not that simple, but we won't go into details. So basically we lose 1 bit of information, and this means that we can only represent half the values in each direction, but we can also represent negative numbers. And if you write unsigned, so no sign, then we can't represent negative numbers, but we have double the positive ones. And so a bit more about integer types here. There's also char. We'll get to that later. It's a bit smaller than an integer. Then we have the int we talked about, and there's also long, which has even more, which is even bigger, so you can store even more values. And if it's signed, you can see the approximate range here, what you can store. It also has, of course, a format string in printf, because printf needs to differentiate between integers and long values. So you have to write %l or %ul if it's unsigned. The same with an integer, you write %u if it's unsigned. If you do it wrong, you will might get the wrong value. So specifying signedness, maybe it was already clear from there, but you can just specify the signedness of a data type in C by writing unsigned or signed in front of it. With most types, the default is signed. char is a bit different, but I won't go into detail.
Okay, then we continue with the char. Okay, yeah, there is probably a mistake with the format string. It should be LU and not UL.
Oh, oops.
Yeah, I have to probably made a mistake there. Okay, yeah.
Okay.
Then we come to the character. And as Julia said it before and listed in the integer types, we treat the character now as an integer. We will later think about it as really as a character, but for now it's just an integer type. Its size is exactly 1 byte or 8 bits, and I think you already know that from the lecture that you can represent 256 different numbers with it. And then we have exactly what we discussed before with the sign char. You have then half of the values, but in both directions. So we have the values ranging from minus 128 to 127. And for this char, it's the same format string in printf. So it's again %d. And if you use the unsigned char, then you don't have any negative values, but you can really go up to the full 255. So from 0 to 255 or 256 different values. And we would print this with %u in printf. Okay, and again, a short example. And we now want to start with a signed char. And we now really write it explicitly here for you. And I create now a signed char called A, assigned value 127. You already know this. And I create a second char. And we call this result A. And we take A and add 1 to it. Okay, and now I'm maybe a bit lazy now and I just copy the printf here. Okay, that's not working. How can I get rid of it?
I don't know.
Okay, so I write it by myself. So if we have A plus 1, so this is, we substitute now the A to really write it explicitly there, and then we get the result. Okay, yeah, that's working. And we print A first and then the result A. And now the question is, what is the output of printf? Maybe, yeah, we have it already in the chat, I think. I think so.
Okay, yeah, oh yeah, we have it, okay, yes.
So maybe we can run it. So you can see we have A plus 1 is 127 plus 1. And then somehow we end up on minus 128. And why is this happening? Because we said before that we only have the range to up to 127. And once we exceed this range, we start from the lowest possible number again, which is minus 128. So we really end up there. Okay. Then we can also do something different here. I do right now the same as before, if I would not miss the keys. And now I write here A plus 1 explicitly here. So there is now a difference here. So here we have really a signed char for the result A, and then we print this result. And now in this case, we take our character and add 1 to it. And then we print the result. So we don't have this intermediate step where we store the result. And now the output is, I will directly run it. the output is in this case 128. Why is that the case? Because here we have this a, which is a character, and the 1 is an integer. And in this case, this a gets transformed into an integer because we add an integer here. So in this addition, we really work with integers and not with characters. And with integers, we have the range up to 2 billion. And for that reason, it really works, and we get 128.
So if you just write numbers and see they are integers.
Yeah.
Yeah, and because we use the format specifier for integer here, and we can print and also compute 127 plus 1 because the chunk is automatically converted.
Yeah.
So maybe we already saw, okay, if you do it with an integer, there's no overflow, but what if we do this? And then we do a result b, and we set this one to b plus 1.
So it's basically the same thing as before.
Yeah, and maybe also print it. I can type. Okay, p plus 1 equals.
The chat already knows the answer, or at least thinks that they know the answer.
The keyboard is confusing me a bit. So, okay.
The keyboard is really interesting.
Okay. So let's just print the result for now. And maybe I will just remove these printf. So just
not
get this
get
one
confused,
out, so we don't confuse.
And we need a format string probably.
Format string. Let's do unsigned now because we have an unsigned character. And let's also delete this. So, okay, now we see it's 128. As you maybe already guessed in the chat, this is because unsigned, now we can represent 255 different values. So maybe what if I change this to 255 now? Don't write it in the chat, we have a Menti question now.
Okay, now it gets interesting.
What happens now if you write 255 plus 1 with an unsigned char?
One more?
Okay.
Oh, seems like you're really fast.
We have a few answers. Okay, so maybe just I'll show you the code again. So we have 255 in an unsigned char. And we add 1 to it. What happens now? And
don't be confused that I think the variable is on Menti named something different than here.
Oh, oops. Yeah.
But it doesn't matter.
Yeah, it's 0.
Why is that the case?
So if we look back, we see a signed char is from negative 128 to 127. So if we are at this top value and add 1, we go back to the bottom and have one negative 128.
And for the unsigned case,
now we had unsigned, so it's from 0 to 255. And now if we add 255, if we add 1, we get back to 0.
Okay, so maybe the question for the chat, was this clear? Or do you have any questions regarding this behavior that we sometimes go back to the range and we sometimes can continue in the range?
Why would someone use char if int has the bigger range? Normally you won't use char for numbers. We'll get to that later. But sometimes you just don't need that big of numbers, and char takes less space in memory.
And also the same thing can happen with integers. So if
Exactly.
you work with really large numbers, then you can also have this problem, and probably you don't notice it then.
Yeah, why is there no error? That's just because C is so close to the CPU, and the CPU just that's the way it calculates. And also, yeah, so we demonstrated this with char now, but that's basically how it works for every other number data type.
Yeah,
Or,
exactly.
Yeah, integer, so whole number data type.
Okay, maybe there is the question from before.
Yeah, okay, that maybe was a bit confusing.
Yeah, so if we have this b plus 1 here, that's the same as before. So this b is a character, and the 1 is an integer. So we have two different data types here. And then there are some rules how to add two different data types. And in our case, the integer is the more important one because it's the larger data type. So in this case, this b really gets transformed into an integer. And then we have b and 1 both being integers, and they can be added again. So the result would be really an integer. And then if we store it in the character again, as here, then we do this back transformation. And if we do not store it, then this back transformation to a character does not happen. And for the reason, we really have an integer number as the result, which can be then larger than 255 or 127 in the signed case.
Exactly. I hope this was clear. So basically, if you want to store an integer in a character, C just throws away the bits that doesn't fit.
Yeah.
And that's what we are seeing here. So let's continue with char a bit, because char is only, we can only, if you do it unsigned, represent up to 255. That's not very much, but so what is the use for char? So you already learned about the ASCII values in the lecture, and here's a quick reminder. So each value from 0 to 255, I have only 1 to 127 here, are encoded as though each of these symbols is encoded with a specific value. And we can't remember all the ASCII values, so there exists char to hold these characters, and also C helps us a bit, and we can enclose characters within single quotes, and they get automatically converted to their ASCII value counterpart. And so we can basically store one character in char, which is already where its name comes from. So yeah, we see here big A has the value 265 in ASCII, and if you write in single quotes big A in C, it's the same as if I would write 65, just that it's now a character. Maybe let's do an example for that. Let's create a character, capital A, and and assign 65 to it. So if we assume what this is doing now is that we have a big A in this variable. But like before, when we printed the character, there were always numbers. So how can we make C print the character really as a character? And this is where the %C format string comes in. So let's print.
No problem.
Let's print this 2 times. First as a character and then as an integer. And we see now that if we use %C, C really prints this one as a character, and with %D, the value of it. So we can use the same. We can do the same again. Maybe, maybe this time for lowercase a.
So would you know the number of it by heart?
I think 90 something.
Okay.
Yeah, it's 97.
Mm-hmm.
But we don't have to know it because C lets us just enclose it in single quotes and automatically puts the value, the correct value, in this variable. So let's check. Oops. So.
And one of the quotes. You can remove one of those.
Oops.
So I think for the next time we'll organize a new keyboard, which is easier.
So let's run it. Okay. So I didn't use a \n. So okay, yeah, I'll just delete that printf.
Yeah, okay. And the new output is now.
Okay, the output is now small a and 97.
Mm-hmm.
So we see if we use single quotes, it's exactly the same as if you would just type in the value.
Mm-hmm.
So this means the characters are just values, and we can also demonstrate this because we can calculate with characters. So we can just do lowercase a minus capital A and print that.
So maybe in between I answer one question. Mm-hmm. Why is the lowercase a 97? That's just by definition of the letters of the ASCII characters. Maybe this is also because the difference that we now calculate has a specific value which is nice to handle or nice to have.
Okay, yeah, so we see...
Maybe you remove the first printf and print it again.
Okay, so now we see first there's nothing, and then there's 32. Maybe now you already know why it's at these weird numbers, capital and lowercase a. You can already guess, but 32 is a very nice number to represent in binary. So the uppercase and lowercase counterparts of each characters are just differentiated with one bit. Mm-hmm. So the bit and with value 32.
Yeah. And what is this character?
So why we don't see anything here? We can go back and check. Okay, 32. Oops, here. It's just an empty space. Mm-hmm. So that's why we don't see anything here.
Yeah.
Were there any questions?
I think we answered them.
Okay, already. Yeah. Why is there free space? Because 32 is the character for space. Mm-hmm. It's the same as if I would just type in the space.
Yeah.
Like that. Okay.
And maybe so if we are here already, you can also write maybe \n here in this lowercase a. No, and in the single quotes.
If I manage to do it.
Okay, should.
Okay, yeah. Okay.
So you may assume now there are two characters in the single quotes, but this also counts just as a single, as just one character, because this \n is then treated as the new line character. So even though there are two characters written, there is really just one character and also has one number representation.
We see here now it's a bit weird, but first we get an empty line. We don't have these slashes there, but first we get an empty line, and then we see, okay, the code for the new line character is 10. Mm-hmm. Exactly.
So we can maybe go up to the ASCII table and also see, do we see the \n?
Line feed.
Okay, so it's not written here, but this would be, has the value 10 then. Okay. So I think we continue with floating point numbers, and maybe let's see whether we do the last part then. Until now we only had integer numbers. We could only represent whole numbers, and now we also want to have a short look on floating point numbers, which are like numbers where we have something behind the decimal point. What are the data types? Float and double. So you can use both of them. We will discuss the difference in the next minutes. We have some problem with them. They are not exact. So because, I mean, maybe you think about your number of choice, and I don't know, it could be, let's say, 0.1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. There are infinitely many possibilities, but again, we only have finite memory to represent them, so they have to be rounded, and for that reason, they are not stored exactly. They are very close, but they do not need to be exact. So even if you have two floating point numbers stored in your C program, which should be the same, they not necessarily need to be the same. Yeah, what are the format strings to print them? %f for the float and %lf long float for double. And yeah, as already said, double is more precise than float. So with double you can store numbers more exact, but nevertheless they're never exactly stored. Okay, so maybe continue with the example. And let's see how much I do here. So if I create a float, for example, or I create a double immediately, and we call it again A. I have to switch now. So with 42, so we can write here 42 as an integer and will be automatically converted to a double, or you can also write maybe some number with something behind the decimal. And then we can print it as we've seen here with LF. Maybe I can insert the \n as well, print the A, and now if we run the code, it should output the double from before. Maybe you can do this for me. Yeah, which is exactly this number here. And now if I continue writing something here, maybe I should do it in some manner which makes sense, and execute the same thing again. Then we see that we have here already some rounding issue because the double is not that precise. Now maybe we should discuss this rounding a bit more because this how exact it is does not depend on how far you away from the commutator, from the decimal point. It's always like this a few numbers from the beginning. So I think for double it's up to 10 numbers, and for float it's 6 numbers. So it's always the first, in the case of double, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers which are really exact. And it doesn't matter where the decimal point is placed. If we have another double which looks maybe something like this, then also again the first 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be exact, and everything starting from here would not be exact anymore. So it really is the first digits, but it's not depending on the decimal point where it's placed. And yeah, that's due to how it's stored in memory. I hope that was clear, my explanation.
Maybe just print B?
Yeah, maybe we can print B, but I'm not sure whether we see too much with that. I hope
no,
it doesn't work. So we write it. And if we print B, then we again have some rounding issue, or in this case it's okay. Yeah, in this case we are lucky. Maybe we continue here somehow and run it again. Okay, now we see that here. Okay, that's that's unfortunate in this case, but basically we have those first 10 numbers which are really exact, and then it can follow, everything can follow. In this case we were lucky that it's really represented that way, but it doesn't need to be that way. Okay, and yeah, that's what I said here. Those, I mean, it can be a bit more, but in the float we have at least 6 digits which are really exact, and double it's the first 10 digits, which are really exact. Okay, that's the part about precision. Should we continue now with the last Menti question, or do we want to go to the stack for the last 5 minutes?
I think we should go to the stack maybe.
Yeah, I think it's also better.
Okay, so let's get to where are data types stored in C. This is something very important, and it's stored on the stack. Okay, what is the stack? The stack is a region in memory where variables in C are typically stored. The stack mostly lies at the top of the memory, and it starts at the top. So if we see here, if we have a variable 1 here on the stack, it starts at the top of this memory region. And it grows down. So the stack grows from a higher address to a lower address in the memory. So we see here, if we have variable 2 here, it gets inserted below variable 1 in the stack. And also we can see maybe if these were just 1 byte long, for example character, then an integer would consume more space than a character.
Okay. Yeah, I think we have it written here.
Yeah, so let's continue with an example for the stack. At the beginning, maybe you can't see this here right now, but line 4 is highlighted. It'll be more clear in a bit. And at the beginning of the main function, there's nothing in the stack. It's not actually true, but for our purposes, there's nothing in the stack yet. If we continue to line 5, we see, okay, we create a new variable and assign it the value a. Then we can see here, okay, maybe at address 255. For simplification, we use low addresses and in decimal. There's the value 97 stored. Then maybe we create another variable and assign the value b to it. Then we create an integer and assign the value 42 to it. And now we can see, okay, a character has 1 byte and this integer already consumes 4 bytes. So this integer is actually at address 250, but it spans up to address 253 because it consumes 4 bytes.
And then if we continue in the code, then we create another character, which we call TMP, which is abbreviation for temporal, so it's just used for a short time. And we assign now the value of mychar. And if we look at our stack, we see that mychar had the value 97. So also in temp, we have the value 97. But the important thing is that those two locations are not distinct on the stack. So they don't have, they don't interfere or something. They're really two distinct locations on the stack.
Yeah, so we basically just copied the value from mychar to temp.
Then we do this assignment, mychar equals otherchar, which means probably you can defer this immediately from the other assignments we had, that mychar gets now the value of otherchar. And that's always also what we saw in the stack. Maybe go back again. So we had 97 in mychar in the picture there, and now it's 98. And then in the next step, we assign the value of temp to otherchar. So otherchar now gets the value 97. Okay.
So this would be a Menti question, but I don't think we have time.
Should we skip it? Okay. So
should we?
Yeah, so maybe ask in the chat then.
Yeah, maybe. What do you think is the output of this program now?
So we have this mychar and otherchar thing.
And we first print mychar and then otherchar. Okay, yeah, we already have BA here.
Yeah, which is the correct answer.
So maybe run it. We have this warning
which we can ignore. Yeah.
But then we can see, okay, we first have B and then have A. So what did we actually do here? Well, we just created some temporary memory location where it stored the value from mychar, then assigned the value from otherchar to mychar, and then this temporary value back to other char, which had the old value of my char. So we basically swapped these two variables, the value of these two variables.
Yeah, and basically that's the first algorithm that we discussed.
Yes.
So swapping two variables.
The first algorithm in C.
In C, yeah. Okay, I think that was the last slide. Maybe just to summarize what we've seen today, we started with the Hello World in C, and you saw in Online GDP how you can run C code and how you can do this then in the virtual machine. We'll discuss this then at the right time, so probably next month. And then we also had a look on the data types in C, where we mainly discussed integers and characters. We saw this weird behavior that we have an overflow. If we add one, that we end up somewhere completely else. Then we also had a look on the floats and doubles, and now we discussed the stack and where the variables are located.
Yeah.
Okay, that's open.
Can we skip this question?
Yeah, we can skip everything. So we can just go to the right until we hit the winner thing. Okay, I'm a bit disappointed that there was no cool animation now. There should be one.
Probably because you skipped the question.
But today's winner is now Simba. Congratulations. And that was everything from our side for today. Again, you finished almost on time, and now you have the opportunity to ask questions.
As always, your questions on Menti.
So maybe go to the last slide. So maybe we can ask the chat, was this now clear? Was this a cool introduction to C?
Okay, we have a question. Should maybe just briefly.
Yeah.
So in the homework at point 2.3, you just have to write the output of git status to a file. Yeah. So I don't want to give you any more hints with what we did in the last lecture. This should be clear, I think.
Yeah. So I take the one question from the chat now. So if I assign for a coding session, I assume in the next few days, I have to do the task on the file you've just shown us and upload it to Teach Center. Yeah, exactly. So you have some date listed on your time slot, and then you just go to the coding session slots. And if your date falls into this period, then you do this task description. And if it falls into this period, then you need to wait for a couple of more days until the task description will be offered. But we try to do it 1 week before your session is.
There's no naming convention, but if you're nice, maybe you write in your matriculation number or your name. We won't be using any IDE. We'll mostly be using VS Code or Codium for this course.
So if we make one mistake within one task in homework, do we lose the whole point? I don't think so. So if it's in general right what you're doing, if there's just a tiny mistake, this should be not a problem at all.
Yes, you should use the virtual machine and code C in there. But you're of course free to use something else.
But for today, we just have chosen another approach just to get started really quickly and do not need to explain how to run your code in the virtual machine. Ja, wie lange finden die Coding Sessions statt? Bis zum Ende des Semesters. I think I will explain it in English so that everyone can understand. There will be 4 blocks of coding sessions. So the first block is now in October, then will be one in November, December, and January. And for each block, you can register once. So you can potentially register to 4 coding sessions, but you only get points for the first 3.
I mean, you don't need to, but maybe it's a good idea to just write some words about what you did with these commands or why you chose a particular command. Yeah. Your submission shouldn't be just a screenshot of all the commands you entered.
Yeah. I think it would be a good thing.
Okay.
Please describe again what an overflow is.
Okay, so the overflow was if we want to store a number in a data type which can store that large of a number. So if you have a really big number or a just big enough number and then add something to it so it becomes a number which is too big for the data type, then it wraps around and starts at the minimum value again. I hope this was a bit more clear.
That make it concrete again what you said. So if we have for the character, for an unsigned character, 255, this is the largest possible number, and if we would add 1 to it, then we would obtain 256.
Which we can store.
And for that reason, we just go to the very start again and have the number 0. It depends on your prior knowledge.
Yeah.
You can do it in 5 minutes, maybe you need 2 hours. And again, it's something, if you can't do one task because it's too tricky for you, it's no problem. The goal is that you really spend some time and put some effort into the pre-work task.
I mean, it depends. If it's on the same Git, you don't have to. Oh wait, no, you can use the same key, so you can just upload the same public key to our GitLab, and then it should be fine.
Yeah, I think so too. Yeah.
Yeah. If it's not too simple, you can choose any command you want.
When is the next Menti Quiz? Probably next week in the practicals.
Ja.
Kleine Frage zur Hausübung. Muss im Report für die Hausübung auch die Erstellung des SSH-Keys und die Erstellung des Repositories in Git enthalten sein? Wie schaut es da aus?
SSH-Key bin ich mir gerade nicht sicher, weil ich glaube, ja, das ist einfach ein Prerequisite. Die Erstellung der Repository könnt ihr einfach kurz beschreiben, was ihr das gemacht habt, weil das ist ja ein Unterpunkt in der Hausaufgabe.
Was ist, wenn wir bei den Coding Sessions krank sind und bereits angemeldet sind? Man kann sich bis zu 24 Stunden vorher noch abmelden. Und wenn es danach noch so sein sollte, dass es also wirklich sehr spontan ist, werden wir auch noch die Möglichkeit anbieten. Das muss ich aber jetzt noch mit dem David besprechen. Das haben wir jetzt da noch nicht drinnen. Wird es dann noch eine Möglichkeit geben.
Wird es mehr Prüfungsplätze für die Prüfung mit denen zur Verfügung gestellt, mit denen es geben, weil bis jetzt sind es nur 15 und die sind schon voll. Ich glaube, es gibt immer genug Platz.
Ja.
Also wenn man sich auf die Warteliste anmeldet, dann kommt man rein.
Ja, ich glaube, wir haben es noch nie gehabt, dass jemand eine Prüfung nicht machen hat können. The VM makes my laptop quite slow, sometimes even stuck. What can I do in order to make my laptop cope better with the virtual machine?
Maybe try turning down the performance settings of the virtual machine. And if it really can't handle the machine, it also should be no problem if you use something like Windows Subsystem for Linux. Maybe just go to the personal question hour and they can help you.
Is it possible to choose teammates for coding sessions? I mean, if you can register for the same time slot if you like.
I work on Windows at home, but got a Mac as a laptop. If we have to take our laptops to the coding session, do I have to install a VM on both devices, and how does this work with Git? I don't think so. I think for the coding sessions, it should be enough if you don't have the virtual machine and just work on your Mac.
Yeah. So basically, Mac, everything is like almost the same as Linux.
Yeah, just check that you have everything on your Mac that you need for these coding sessions. So maybe if it's a later coding session that you can compile your programs and run them, but then you should be fine.
Mm-hmm. And how does it work with Git? Is this a problem if you have it on 2 devices?
No, you can just generate a new key on your laptop and add this key on GitLab like you did it with your first device, and then both work.
Mm-hmm. And can we even clone repositories on both devices?
Yeah, you can clone the same repository on both devices, and then like we showed it, you can add files, commit them and push them, and then on the other device pull them, and then you have the same on both.
Will there be another homework with the contents of this lecture? Not of this lecture, but this is like
more like of in general.
Yeah.
Yeah.
But this is basically a foundation for the assignments.
Yeah. Yeah, what we did in this lecture you will probably need in all assignments and at the exam and in your future studies.
Yeah.
No, there exist probably very, very many commands and different ways of creating files on Linux. You can look that up on your own.
Mm-hmm.
Yeah, sorry, we rushed that a bit. So the stack is just a region in memory that's organized in a special way. So it grows from the top to the bottom, and the C compiler stores your variables there and adds them always on the bottom of your stack.
Mm-hmm.
Mm-hmm.
I did point 1 before I saw what the homework is. Should I do it over again, or is there an easier way? Do you remember what point 1 of the homework was?
I think it was a Git setup.
Mm-hmm.
You can just describe the commands which you executed in your report. You don't have to actually enter them, maybe.
But maybe let's see what this is about.
Yeah, it's Git.
Yeah, so you can create another repository. We can reclone the repository from before. Yeah.
Yeah.
And also you can execute the config commands again. It's no problem. Muss man beim Pre-Work auch einfach ein PDF mit Screenshots, Comments von der Aufgabenstellung abgeben? Ja, genau so ist es gedacht. Also sehr ähnlich zum Homework eigentlich, nur ein bisschen anders mit anderen Befehlen.
Is there a deadline for the coding session preparation? Can we hand it in online an hour before the session?
It needs to be handed in before the session, and it's enough if it's handed in a second before the session.
In the Notion web page it says pre-installed program. Do we have to install them inside the VM or outside the VM? No, this section, everything, all the programs that are there are installed in the virtual machine. That's why it's called pre-installed programs. It's just for if you want to work outside of the virtual machine or can't work in the virtual machine and want to do it on your own setup, you can, if something doesn't work, you can look at this section, what the programs are that are installed in the virtual machine.
Mm-hmm. There is a group selection segment on Discord where you can choose your teaching assistant. Is the teaching assistant the person with whom we discuss our assignments, also Abgabegespräche? Yes, but you do the group selection after you were assigned to a group from us, and this will be the case in November at some point.
So you can't freely choose your tutor. You just have to wait until you get assigned your tutor, which will be when we hand out the first assignment.
Yeah,
and then you can go on Discord and select the correct group, so you are in the right channel.
Ja, exactly. Wenn man einen Unterpunkt verhaut, verdient man dann einen ganzen Punkt, also bekommt man den Punkt, und wenn man alle Punkte korrekt gemacht hat, wie schon gesagt vorher, wenn es ein kleiner Fehler ist, ist das überhaupt kein Problem.
Es muss nicht alles 100% korrekt sein, wenn alles grob so passt, dann sollte man einen Punkt bekommen.
What do we do in coding sessions? Yeah, you prepare for the coding sessions, and then the coding session will be about this topic, and you will discuss about these topics with the other students and the teaching assistants in the coding session.
Yeah.
Yeah, basically what I said, I think.
I'm not quite sure if alias has any more arguments than just aliasing two commands. I think if there aren't any more arguments, then it's too easy. Maybe. Okay, no. Yeah, no. So if it doesn't, I'm not sure if it has any more arguments, but it's just, if it's just alias command equals command, then it would be too easy.
Whereas Leersar 9, so we go to the coding sessions, slots for the first coding session, and then we have a location here, and Leersar 9. If you press this, then you get to the info, and I think if you press on the location, you can find it here, and you can go step outside, and you see it's somewhere located here in the Infeldgasse. And as I saw this in the questions, I go back here. I just want to show. Okay, yeah. So because there are next to the location, there's also printed EN or DE. This is just the language the coding session is held in. So there are some English ones and some German ones. Okay.
If you copy something from the internet, then yes, please quote that.
Yeah.
Also, if you copy something from the man pages, but if you use the man pages just to get some information and write it in your own words, then it should be fine.
Can you explain 2.4 and 2.5?
We still have it open.
But I don't know where.
Probably in the homework.
Yeah.
Oh, okay.
Yeah.
2.4, 2.5. Yeah, just verify in any way you like, but it has to be on the command line that the contents of the just created file are correct. And then 2.5, go back to where you started before switching to the newly created directory.
So basically one command in each subtask. And the last question of today, whom should I contact if I want to reset my password for the virtual machine? I've used a random generated key and didn't save the key pass file.
For the virtual machine, you just have to reinstall it.
Yeah.
So, yeah, delete it and install it again. We can't do that. Yeah.
But it's no problem. And if you have uploaded everything to Git, then everything is stored. And if you use a shared folder, for example, in the virtual machine, then you also do not lose your files that you have in the VM. Okay, I think that was it for today. And as there didn't pop up any new questions in the last couple of minutes, I think we're done for today. Maybe we'll go back here.
Thank you for joining us today. I hope it was a bit less confusing than last time, but I think that's always the first lecture. And have fun with the homework. Don't forget to register for the coding sessions, and you see us next week on Thursday with, I think, very interesting topics. I think so too. It will be much fun.
Then have a nice evening. Bye.
Bye.